Okay, we're in chapter 3, the fourth section. It is direct variation, and it deals a lot with slope. Okay, it says a direct variation is described by the equation y equals kx, where k does not equal 0. Direct variation just simply means if one variable gets bigger, so does the other variable. If x gets smaller, so does the variable y. K is simply slope. Okay, we learned what slope was. K is different because it describes direct variation, or we always start at the origin 0. Sometimes we don't always start at 0. Okay, the equation y equals kx illustrates a constant rate of change, and k is the constant of variation, or the constant proportionally. So where you might actually see this, for example, is a job. Okay, we start in real life at the origin. We start at 0, 0. So when you're starting a job, you're going to start at 0. And you might have a rate. You might make, let's say, $10 per hour. Okay. So money is going to equal $10 for every each hour you work. Let's say you work 5 hours. You're going to make $50. Say you work way more. Say you work 10 hours. You're going to make $100. So as your time and hours got bigger, so did your output. As your time, or as your hours of working got even more, so did your output. So as X gets bigger, Y gets bigger. And as X gets smaller, so say you work less, your output's going to get smaller. Okay. It says name the constant of variation for each equation. Then find the slope of the line. Okay. Name the constant. Well, the constant of variation every single time is going to be your K or your slope. It says then find that slope. K is M. So right here, you can find it between the 2 points, or they just straight up tell you, here's your K, 2/3. Okay, then find the slope of the line that passes through each point. Well, that's the same thing. K is your slope. They're the same thing. So you don't even have to write K or M, just write your constant is -5 for this one. It's the same thing. You went down 5 and you went to the right 1. So it's -5. Okay, the slope of the graph y equals k is k. Slope is k. I've already said that to you. Okay, you're supposed to kind of discover it on your own. So we're reiterating it. It says since 0 equals k times 0, the graph of y equals kx always passes through the origin. So what they're saying is when x is 0, 0 times anything is going to give you 0. So we always go through the origin. Always go through the origin. Yeah. In real life, you're going to start at 0. When you're born, you're 0. Money, 0. Okay. It says graph the equation. So every single time we're going to start at 0, right? 0, 0. -3/4 is your slope. So you just have to move. You have to move from your slope. So K or your slope is -3/4. So you move with your slope. You go down 3. So I don't care where you put the negative, just put somewhere. So down 1, 2, 3, and to the right 1, 2, 3, 4. And then opposite up 1, 2, 3, 1, 2, 3, 4. You need to make a straight line. Okay, so I want you to pause the video. I want you to try the next 3. Make sure you pause it. This one's technically over 1. So go up 1, 2, over 1, up 2, over 1, up 2, over 1, or down 2, left 1. And what that would look like is down 2, left 1 is the same thing as 2 over 1. Okay? Down 2, left 1, down 2, left 1. Okay, that's it. All right, in this next one, you start at 0, 0. You can go up 2 to the right 1, up 2 to the right 1. I'm sorry, why am I saying 1? Up 2, right 3. Up 2, right 3. It's been a long school day. Okay. Connect the dots. Okay. And the next one, technically that's a -1. So your slope or your constant is -1/1. So you start at 0, 0, always the origin, and you go down 1, right 1. Down 1, right 1, or up 1, left 1. When you connect the dots, this is what you're going to get. All right. Flip the page. So it says concept summary. The graphs of direct variation equations share some common characteristics. They all pass through the origin, no matter what. Direct variation equations are in the form y equals kx, where k is never 0, or slope is never 0. The graph of y equals kx always passes through the origin. We just established that. And the slope is positive if it goes up and to the right, or the slope is negative if it goes down. Okay? So if a relationship between the values of y and x can be described by a direct variation equation, then we say that y varies directly as x. So if we can write this equation, we say y varies directly as x. Suppose in example 3, y varies directly with x. That means that we're allowed to write this. It says y is -8 when x is 2. Find the constant of variation k. So we need to find that constant of variation. To do that, we need to get k by itself. We did. K is -4. So that constant, our rate of change every time, is -4. It says then write the direct variation equation that relates x to y. Okay, so if we were to write an equation, the equation would be, y equals, because y is going to be different every time, x is going to be different every time, but our k is constant. That's the point of it. This would be an equation we can use for any other information. So find the constant of variation k, we did. Write the direct variation equation, we did. Use the direct variation equation to find x when y is 12. So I'm going to use this equation. Y is 12, k is our constant, which never changes, and now they want us to find x. So what is x? X is -3. Example 4. Suppose y varies directly with x. Y equals kx. Y equals 9 when x equals 3. Well, -3. It says find the constant of variation k. So I'm going to divide both sides by -3, and I'm going to get k equals -3. And then write a direct variation equation that relates x and y. Okay, so my equation is y will always be different. K is not going to be, but x is going to be different as well. So here's my equation. Use this equation now. Use the direct variation equation to find x when y is 15. So y is 15. K never changes. What is x? Remove -3 from both sides. And x is -5. So, and both of these are the same thing. They wanted us to find a k, we did it. They wanted us to write an equation, we did it. They wanted us to find new information, we did it. Example 5. Joe's wages vary directly as the time he works. So Joe's wages vary directly as the time he works. Joe's wages varies directly as the time he works. So y is our wage, x is our time. If his wages for 20 hours are $150, what are his wages for 38 hours? So But what we could do is we got to figure out K to find the new W. So we divide both sides by 20. Okay, this is going to become K equals 7.5. So our wages here are $7.50. So your wages are $7.50 for how many hours you work. So that's our new equation. We're going to put in 38, but we need to know K as well. And you're going to get 285. Okay, another way we could have done this is a proportion. Since they start out the origin, we can say the comparisons are equal. So another easy way I could have done this, if I'm just trying to find new information and not write an equation, if I'm just trying to find new information and I wasn't required here to write an equation, what you could do is say, all right, 20 hours, $150. I have 38 hours. How much money is it going to make? And you could just cross multiply and say 20x is equal to, okay, you could say 20x equals 5700, divide both sides by 20, and your answer is 285. You could have done that. Okay, so either one. So let's try the next one. It says a student completes math problems at an average of 2 problems every 5 minutes. At this rate, how many math problems does a student need to complete in 65 minutes? So they're not asking for an equation. They're not asking for a K. They're simply asking for a result. So I could say 2 problems every 5 minutes. So minutes, problems. So then we're going to line up problems and minutes here. It says at this rate, how many math problems, how many if it's 65 minutes? So we could just cross multiply here since we don't need to write an equation. If we needed to write an equation, then we should have done something else. That's it.